Factor the polynomial. To factor a polynomial that has an a value greater than 1, the easiest method is factoring by grouping. And to do that, we need to take our a value and multiply it to our c value to start. So a is the coefficient of our first term, b is the coefficient of our second term, and c is our constant, right? So a times c is going to be 3 times 20, which will give us 60. Now we need to take 60 and list out as many factors as we can so that we can figure out what two terms could be added together or subtracted from one another to give us our b term, -7. So let's start by listing out these factors: 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 5 and 12. And we'll stop there for now. 1 plus or minus 60 would not give us 7. 2 plus or minus 30 would not give us 7. 3 plus or minus 20 would not give us 7. All of these numbers are too far apart to give us a number as small as 7. 4 and 15, we're getting closer. If we were to subtract 4 and 15, we would get 9. 5 and 12, if we subtracted 12 from 5, we would get 7. So this is the pair of terms that we're going to need to go with. And to figure out what signs we should apply to those terms, if our result should be negative, that means the biggest number of our two factors should also be negative because the largest number carries the sign. So we're dealing with a -12 and a +5. Now we can rewrite our polynomial, but instead of -7x, we can split it up into two factors, -12x and +5x minus 20. This is an equivalent expression to what we have up here. But expanding it like this, giving it 4 terms instead of 3, allows us to group those 4 terms into 2 binomials and then factor out the greatest common factor of each. So for this first set of binomials, the greatest common factor is going to be 3 and x. So we're pulling out a 3x. What's left over, 3 divided by 3 is 1, x squared divided by x is x, minus 12 divided by 3 is 4, x divided by x is just 1. Then over here, our greatest common factor in this binomial is 5. So we're pulling out a +5. What's left over, 5 divided by 5 is just 1, x, minus 20 divided by 5, which is 4. And we can rewrite this if we'd like, 3x, x minus 4, instead of 1x is just x. Anything times 1 is just itself. So now we can see that we have 2 matching binomials here, and that is going to be our second set of binomials in our factored form of this polynomial. And then our first binomial in this factored form is going to be the combination of the 2 factors we pulled out, right? So 3x plus 5. So the factored form of our polynomial is 3x plus 5 times x minus 4, which matches answer choice D.